Howdy, my name's John Nicholson. I work at Broadcom here, do technical marketing for vSAN, and work within the storage area and as it pertains to the VMware Cloud Foundation stack. So today we're going to talk a little bit about what's new on the storage side within VMware Cloud Foundation 9. So going over some of the areas, I want to go over some of the operation tooling, start at kind of the strategic capabilities that we've brought out within 9, as well as help you understand some of the tactical tooling we have to answer the age-old question of why is this slow. We'll talk about some of the key capabilities within vSAN 9 and other capabilities that are brought out. So going over kind of at a high level, there's 4 major themes of improvement. We've got improving the cost of operations. This is going to be driven primarily by the new global deduplication. We also are adding additional disaster recovery capabilities, vSAN to vSAN replication and integrations with live recovery. And then we also have new performance capabilities and general security improvements across the platform. And this last area that we'll actually start with a demo on is going over some of these new operational consoles and abilities to understand what's going on across your estate. And now I'm going to transition over to the demo. So looking at these multi-site operations, if you've got one cluster, it's great that you're going to work within vCenter normally, but in a larger environment, we're going to use operations. And we have these new capabilities. We can see all the alerts in the environment. We can see all the clusters I have here. I can also see their configuration. I can see the health scores that are rolling up. So if there were environments that were having performance problems or other capabilities that would get surfaced, I can see what kind of vSAN cluster they are, whether they're the new express storage architecture. I can also see compute clusters, which are clusters that are just consuming vSAN storage. And then on the right here, I can also see those cluster performance capabilities. And I can see not only how many IOPS I'm being delivering an environment, but also what that latency looks like across this environment. We have this new diagnostics capability, so I can actually go look into clusters and troubleshoot and see what's going on. And I can pick a time window and trying to understand, is there something wrong in this environment? In this cluster, the initial cluster I have, if I go look at this and run this troubleshooting, I may discover, across a specific time, I don't have issues because my cluster obviously has no great performance issues. But if I did, I might see other capabilities. Now, if I want to look deeper into what's going on with a workload, we have a capability native to the vCenter server called IO Insight. This is actually going to run something called a vSCSI trace. It's going to like a DVR for the entire storage IO path of that virtual machine. Now we're going to select which virtual machines we want to run this for. So if you're trying to understand a workload and maybe you're migrating a workload into a new environment and you want to get a better picture of what's going on, this is going to help give us a lot of visibility into what the actual IO path is doing on a virtual machine. Traditional monitoring often works on a random sampling or polling basis. This is kind of nifty in that this is actually going to capture all of the IO that's going on in that environment and actually trace through what the actual performance demands are that we're running during that period. And if I have it also within an environment, I'm able to capture these and create these instances and go through. Now, if we go look at the actual performance that's been captured on these workloads, we can see the amount of IOPS that have been that are being from a top talker's perspective. So we can see the top VMs in my cluster in terms of what performance demands are being made in the environment. And since I've had these captures running, I can now go view them. So I've got a logs appliance I'm going to go look at. And this is going to break down on a per VMDK basis. I can see exactly what the performance, the throughput. But if I scroll down here, I can actually see the distribution on the block size and the latency distribution. So rather than get a simple average, which may hide some outliers, in this case, I can see on my high side, I'm 1 to 5 milliseconds, but on my low side, I'm in the microseconds. On my block size, I see that I've got a couple very large blocks, but most of this is 4K. One of the challenges a lot of times is if you look at a lot of just general performance capability gathering, it'll often average this out. But with this, we can get the exact requirements of what it's running on. Now, this other tool I'm using here is called Trip Analyzer, and this is going to show the end-to-end I/O path of that virtual machine and the disks and where they're located. Now, if I was having performance problems in an environment, this will actually surface in red the individual component. But I can also drill quickly in. And so if I'm trying to trace down where latency is coming from, this is going to help me map it end to end. So I can see I'm looking at the individual devices. I'm looking at actually the raw firmware latency coming off that device. So if that drive was either overloaded or had a problem, I can also look into the network hops. Now, historically, as a storage admin, if I wanted to do end-to-end troubleshooting of an I/O path, I might have to log into my fabric switches. I might have to log into my hosts and go look at ESXtop. I might have to go log into arrays themselves. I'd have potentially to look at multiple places to understand that I/O path end-to-end. But here, we're able to capture what the actual performance impact of every single hop is, because we are both, so to speak, the client and the storage platform. We are both sides of this.
And I noticed that this is using a ESA architecture for the storage. Is this also available with the OSA, the original storage architecture?
The IO Trip Analyzer. So these bits, IO Trip Analyzer has been out for a while. So yeah, I believe that also is available with OSA. The vSCSI trace capabilities, those have also been available in regards to that.
And the second question on that is, what's the overhead like if we are putting these traces on? Is this you use it briefly while you're troubleshooting an issue or planning for a performance upgrade, or is this a more general purpose monitoring tool that we might use more widely?
So the last time I talked engineering on this, I think it adds about 1% CPU load to a host. It's not something that we generally run 24/7, but you can schedule those to run. And people do if there's a specific virtual machine on. The overhead is relatively low, but it is there. It's not. That's why it's not on 24/7 currently. That said, the general performance service is running 24/7, and it is capturing that data. That performance service, by the way, has been improved where the current poll interval is now 30 seconds. However, if you really want to go nuts, if you go into the cluster settings, you can actually turn on what's called network diagnostic mode. And for 24 hours, we will run a 1-second poll interval specific on the network stack, which if you're trying to identify microburst related performance issues, or maybe things like you're concerned on switch buffers or on a leaf spine linker being oversaturated, that 1-second granularity is really nice.
Hey, John, I noticed in the demo that you started out in the ops console, but then a lot of it looked like was in the vSphere console, unless I was
yes.
wrong. So do you expect the storage admin to spend more time in one console versus the other, or is some of that functionality, the new functionality you showed within vSphere, going to make its way into ops to give it that single pane of glass, to overuse a cliche?
Yeah. It's always about pain, or at least trying to avoid it again. So some of those things, that actual storage diagnostic, that actually was originally a vCenter only feature. And we've moved it to ops, and a couple of things have happened there actually under the hood. One, that previously required a cloud connection to run. And we've removed the need to go use the cloud. The ops is your cloud, so to speak, for that functionality. Also, it used to be limited only to diagnosing HCI bench performance benchmarking runs. Now it just works for general troubleshooting. So that's an example of something that started in vCenter and we moved over. The other thing, though, from a general where I expect an admin to be, is I expect if I'm looking holistically across my fleet, if I've got multiple clusters sprawling out, tens, hundreds of these things, or I'm looking at general capacity trends, I'm going to probably spend my time in ops. If I have a specific virtual machine that someone is asking me about, and I'm trying to drill into the tactical why that's slow, I'm probably going to wander back into my vCenter server. However, obviously there's links between the UIs to hop between them. That said, the general trend is trying to move as much end-to-end to ops as possible.
From that standpoint, I remember back in the day, it's been a while since I've been a vSAN admin, having to hop through the vCenter console at various places. If I lost something in my vSAN cluster, an entire host, a single drive, whatever, and I want to view resync status, affected objects, stuff like that, I knew where to find that. Is that going to make its way into ops at some point? Is it still going to be you have to know the right place to click within vCenter? What's that going to look like?
So what's driving a lot of that from a UI simplicity is actually when you click on health alerts and things like that, it tries to drive you into that. And some of that stuff I showed you there, like with the IO trip analyzer, is there's all these different performance dashboards and they're scattered across all the hosts and the VMs. But if you're using that view and it identifies a red area, it'll let you drive straight to it. So kind of our designing goal here is to try to make it to where you don't have to memorize the 14 clicks to go understand things. And if you have a health check or an alarm that's going off in ops, it should take you straight to where that is. And some of that you've seen previously with the vSAN Health, to where if there's an issue, you can click the troubleshoot button, or you can click okay, what's the relevant KB for this? We try to make sure all those health alarms and rollups that go into ops and the vSAN Health service have those capabilities.
Looking at historical data, how far can I go back in time?
So operations can hold data for years, I believe. The vSAN performance service tends to hold about 90 days on its own, but that data is going to get rolled up into ops. So for your longer term retention, you're still looking at ops. It is worth noting that the vSAN Health service, I believe, has at least 90 days. And you can also, there isn't actually an option within the UI to say, show me what previous alerts have gone off. And I can see the historical track for those alerts. So the other thing that we're bringing kind of back in a way to vSAN is deduplication. So we had deduplication with the original storage architecture, but it had a lot of limitations. And we've brought now with vSAN ESA, when it initially launched, we just had compression. We wanted to make sure we refactored deduplication and really got it right. And so we have this capability today. And we're calling this cluster-wide global deduplication. This is launching with limited availability. With 9, there's going to be a request for technical approval. Basically, you fill out a form and you can get access to it. Some things that are definitely improved with this. We are using a 4K fixed block granularity. I see quite a few storage people on this call, so I know that may mean some things to you, which is generally pretty granular in terms of that. We also are going to dedupe across the entire cluster domain. Previously, with original storage architecture, it was on a per disk group basis. And so if you had 3 disk groups in a host and you had 5 hosts, you could have 15 dedupe domains. We are going to run this asynchronously. This is not sitting in the write IO path, so it will not impact write performance. And it's going to adaptively throttle and run based on there being available performance resources in the cluster for it to run on. This does integrate with some of our other capabilities, snapshots, compression, and so forth. And we're looking to expand this out. From a under the hood, kind of how this works is we're doing a post process. We're going to go through, we use a secure cryptographic hash that's SHA-256. So we're not really worried about collisions in regards to that. And we will create dedupe metadata objects that as we find that, we single instance that data out and grovel that if we obviously find no matching. We are going to do some sharding across the cluster for scalability and performance and make sure this gets balanced and try to keep large reads contiguous and not cause excessive fragmentation across the environment.
So I'm sure like every customer is going to know, okay, how much can I save with dedupe? And that's an impossible question to answer.
I love that question. Yeah.
But I guess my follow-up is like, if I enable it, how do I know if I'm seeing the full effects of it yet, or if that async process is not yet done running and I should hold my horses to look at my own stats to see how well it's working for me?
What we expect is most people are going to set it up for initial cluster setup. In regards to that, and just set it across the array. So as you copy data in, you will get more benefit. Now, one challenge with dedupe, as you say, how much data will I get dedupe is the great question of life. How many roads must a man walk down? The answer must be 42, I guess. But trying to do that, one thing to keep in mind is 2 things will impact this. So one, the more data you put in, obviously the more data you put in, this will scale it. The other thing also is you can keep growing that deduplication domain. And so, as you grow that cluster, the more and you add more data, the more opportunity for duplicate data. Some people have tried to create various, workflows over the years and say, oh, let's have a groveler agent or let's pre-scan data or let's do things. There's kind of madness in that. I would, anecdotally expect maybe a 4x, between compression and dedupe. But again, if you're doing full clone VDI, that dedupe ratio can go to the moon. If you have encrypted video data, obviously that doesn't dedupe well because it's high entropy. One of the things to think about though is from a vSAN density, from the scale of this, if you've got 1U pizza box servers with 20 NVMe drive slots and you're putting 16 terabyte drives in those, and you've got maybe 6 of those hosts, that's going to be about the same capacity as the median third-party array out there. But you can keep expanding that vSAN cluster out, and these things can grow quite large. I mean, you can have many, many petabytes of raw vSAN within a cluster. So these dedupe domains we expect to get rather large in capability. And from a perspective of, sizing, that should be able to produce some pretty good deduplication as opposed to the older architecture we had with the original storage architecture where that dedupe was limited, not just even to per host, but per disk group, or a per array based dedupe. And again, comparing that per ESA, if you looked at that, we had those relatively small. The original storage architecture also ran inline. It was during the cache destaging, and that could be a bottleneck. So sustained writes, it was performance negatively impacting. And in regards also with resynchronization, if you worked with the old vSAN ESA, if you had a drive fail, it would fail that entire disk group. So now you could potentially have multiple drives that needed to resync. With vSAN ESA, one drive failure is just one drive failure. So that data just needs to be resynced elsewhere across the cluster in many, many actions. So we are seeing significantly faster resync operations with this architecture. And the compression, by the way, does still happen before first write. And so that actually is partly to help us with network usage efficiency. We compress before we hit the network. So from a activity of this feature is coming out with patch 1. We are doing some initial limitations on this request for product qualification. We're going to we want people to have phone home on, and we're also limiting cluster sizes to 16 nodes initially. We're also wanting to see 25 gig networking at a minimum, which you really should be at in the year 2025. And then we've got some other limitations on features. We're doing additional QA testing. Any questions on dedupe there?
I see a higher and higher request for encrypted storage. And in that case, deduplication doesn't make much sense.
So their compliance is requiring encryption storage. You are correct. If people encrypt at the application level, then that effectively does break deduplication. That's an inherent limitation of it. However, we do offer data at rest encryption, and we do offer data in transit encryption. So vSAN, ESA by default actually encrypts before it hits the wire, but we will actually apply an additional rotating cipher, much like vMotion encryption. So we can meet the highest of compliance requirements by doing encryption on our side. Again, if you're doing app-level encryption, that obviously is going to have impacts. But we can meet a lot of those compliance requirements using our encryption where possible and hopefully keep that data to where we can still run compression and dedupe, but compliance will differ. Some other things to keep in mind is VCF in general, its support of how we do vSAN and broader support of capabilities. We're now supporting multiple different vSAN deployment types. So we can do single site cluster. We can do what are called disaggregated or storage clusters. This is the artist formerly known as vSAN Max. So we can have these clusters that basically act as a storage array. And we can also import clusters that are stretch node and import 2-node cluster. So historically, VCF, it's been a great platform. We've had it for a very long time, but adoption historically was low because we had a very, it was greenfield only. You had to deploy it a very specific way. Your existing workloads, you would have to, basically repay vMotion everything in and repave that stuff over. We now have pretty broad support to import your clusters as they are and meet customers where they are on those capabilities and bring them into the VCF lifecycle workflow. And so we have these ability to do these converge and import these clusters and capabilities.
Hey, John, quick question on the previous slide. It's probably a little detail that means nothing. But I noticed that we've got a workload domain that has a stretched cluster in here, but the management domain does not appear stretched. I thought those were, codependent on each other in the past, and maybe that was just a detail that wasn't left in the slide that you must have a stretched management cluster. to support stretched workload domains, unless that has changed with VCF 9.
I'll have to defer to my VCF team on that, but I believe you can actually import a stretched cluster that is independent of the management being stretched. I believe that was the case, but I'll have to refer you to docs. So, but you're right. That's the kind of like weird rigidity that we've had historically, and in general as a directional. We're trying to move away from that. We obviously have strong opinions on architecture and things like that, but we also understand that waiting for someone to depreciate servers for 7 years and recycle them in order to adopt BCF, that's going to take too long. We've got to meet people where they are. So speaking of storage clusters, when I go talk to customers historically, we'd pitch vSAN and say, hey, look, we've got hyperconverged architecture. This is great. And then they'd say, well, I have this asynchronous storage workload, or I want to disaggregate. I want to have very small client clusters, maybe for a workload for licensing or other reasons, something like Oracle. And so we came out with a system to be where we can have these storage clusters and segment these. One of the limitations we've had in the past is that all of vSAN would hairpin all traffic through a single VM kernel port. We now have the ability to disaggregate this. We can run separate networking. And so you can go build this vSAN storage cluster, hopefully using modern 25 or really at this point 100 gig top rack switches. But then you can have a separate VM kernel port that talks out to the existing hosts over their existing networking. And what you can do here is, let's say you've got a legacy environment that's got 10 gig. You could have one connection that goes into that network, and then you could have a separate backend network used for the vSAN network and spread this out. And what this looks like in the UI is we have an additional VM kernel port now for that storage cluster traffic, that backend traffic. And as you can see here, if you've followed VMware for a while, we've actually added quite a lot of VM kernel ports over the years. These things are kind of like Pokemon. We've got to collect them all here. At some point, I probably do deserve for everyone to have a blog that we create that just explains again, reminds everyone of what all these things do. But we also have the vSAN Witness also is another one that you can split out. And when you do your cluster setup and you're setting up a storage cluster, you'll need to set this up to use the split networking. It's just a single slider that will then prompt you if you've already assigned those VM kernel ports. Do note there's other settings here like RDMA support and at rest encryption you'd set up at the same time. So from an architecture, what this looks like, these storage clusters, we've got the traditional HCI. This is great, but people may not want to do this for many reasons. Sometimes it may just be personal beliefs. They really like having separate storage. We have data source sharing that we released back with, I think it was 7 update 2, to where you can basically borrow capacity between clusters if you have some stranded computer storage. And then we also have fully disaggregated storage. And this allows you to have discrete compute clusters and build out those storage clusters. And some people may want to go really big with this. I see people create multi-petabyte storage clusters. Sometimes they just want to have an 8-node cluster and they just want to run 3 nodes here, 5 nodes here, 6 nodes here for compute. They split that out. It really is up to the customer in terms of their needs, their applications, their workloads. It is worth noting that with VCF, the customers are entitled to 1 TB raw per VCF entitlement. So, if a customer has 1,000 cores, they have 1 petabyte of vSAN. So for a customer who maybe is transitioning to this new licensing, may suddenly discover that they have a lot of vSAN. This is an opportunity maybe where they just go build out a storage cluster and take care of that storage refresh need that they currently have. While their existing compute clusters, maybe they're blades, maybe they're still depreciating them, maybe they just have enough compute. They can go run that as they see fit. I did want to talk a little bit about data protection. So we have a new vSAN to vSAN replication capability. This is something that's been asked about for a while. We initially launched a vSAN data protection capability in the 8 train, and this was a built-in snapshot and snapshot retention engine. But as everyone has always said about backup since the beginning of time, it's great that you have a copy of that data, but unless that copy is copied somewhere else, a snapshot by itself is not a backup. It's definitely been a hill that many people want to stick to. So going through these capabilities, we've extended the vSAN data protection, which is included in the base vSAN. That's definitely there. You can create those GFS schedules You can create those snapshot retentions. You can set immutability on those. But we now have the ability to combine this with the VMware Live Recovery add-on. And VMware Live Recovery, for those following along at home, is it incorporates the product formerly known as Site Recovery Manager. We can now replicate those VMs. And so we can set that replication interval. We can get a 1 minute recovery point objective, and we can keep not only, a set of, GFS on the source side, we can also keep an X number of snapshots on the target side and that capability. And we can also set protection groups. And so we can automatically create these groups based on things like VM names. So I can have everything with prod in the title get a specific policy, or everything with finance or HR get a specific policy. But this allows us to do replication and do disaster recovery. And then using the other capabilities of live recovery, the orchestration capabilities, the runtime, the testing capabilities, we can bring this up. And so this also is helping give us some additional protection, not only from traditional disasters, but also things like ransomwares. Remember that additional cluster you're replicating to that can be in a separate SSO domain, separate authentication environment, and so forth. To help simplify this deployment, the OVA that's used for vSAN data protection, that's used for vSphere replication, and that is used for VMware Live Recovery, that's actually all one appliance now. We've deduped the appliance, so to speak, to where you now have one appliance that is serving those multiple functions.
Okay, so you answered a question I had, John, which was, would this replace the vSphere replication appliance that VLR SRM customers know and love in the past when they needed to replicate data between vSAN data stores? And the answer is kind of, because it's on the same appliance, but it's different functionality. Is that right?
Yeah, it's a different functionality. So in order to have those scheduled snaps retained on the other side and using the vSAN, we are going to require that license and that capability. But for just basic replication, it's still the same OVA. And when you log into it in 5480, you'll actually, or in the admin portal, you'll see basically it does call out that those three services are basically set up there. But the goal also is, if you are going and creating a workflow, you can go through, and I apologize, I don't have a demo for this. I was just getting this up in my lab last week. But when you're you're setting up this workflow and you create the snapshots, and then you say, oh, by the way, also replicate it and keep this number of replicas, it can also go ahead and pre-populate that into that live recovery console. So that way it's ready for your run books and those capabilities are there. And I will say, again, apologies not having a UI demo here. The UI is really well thought on this, and it shows that there's really trying to simplify these workflows and make it easy to protect things and those capabilities. And what I expect some customers to do is combine some things here, potentially using the vSAN storage clusters, and maybe create like a giant, just storage disaster recovery target in a central location, and then maybe fan in replicas from multiple environments in. We're also just improving some of the capabilities across this in terms of, we now have within VCF, there is stretched cluster support for running stretched clusters on top of vSAN stretched clusters. We also have a new capability to do site-based maintenance modes. You can basically put an entire site into maintenance mode. This has come up. I get this a lot from European customers just because there's so much stretched cluster activity. They may have a site that they want to do extended maintenance and proactively handle that. A third improvement that's come up is, well, we have stretched clusters and those automatically fail over because the witness site manages that quorum. We have some customers who are concerned about a kind of an outer scenario where the witness site fails and then one of the site fails. Historically, we would demote the surviving site because split brain protection kicks in. People want to be able to do a forced recovery takeover, and that is something we actually are now going to extend in. So again, stretch cluster capabilities. This is a true synchronous active-active. Those virtual machines run on both sides. They're being replicated in terms of those workflows, in terms of those capabilities. Those virtual machines, and you can select a subset of VMs to replicate and do kind of an asynchronous if you wish. But we are now giving you the ability to basically put one of these sites completely into maintenance mode and initiate that. And so we've got these fault domains. We can select one of these that we want to put into maintenance that will initiate a proactive evacuation. So DRS will initiate vMotions off of that. And then all of those hosts can go into maintenance. There's different reasons. A lot of this is physical maintenance. People are maybe doing power or other infrastructure maintenance, or maybe they're migrating one of those two sites or things like that. We do have a lot of pre-checks so we'll basically tell you anytime you're putting hosts into maintenance mode, or you're putting a site into maintenance mode, we'll tell you what the impact will be, how much data potentially has to move if that action's happening. And this is available also by API, so that can be fired off.
If a customer wants to use that as a way of testing their DR plan, is that an acceptable use case for that, or would you recommend a different kind of workflow?
So that will because that will basically limit you to running everything from one side, and that makes sure there's a healthy copy of data on the other side. A true DR plan, at the end of the day, some people really are just going to want to throw the breaker to the PDUs on one side. And I respect that. Some people will just want to say, okay, we don't actually want to product, because that triggers an HA event. This is definitely a way to do that, is do that proactive evacuation and of emotional work. And then you test your applications, and that'll give you awareness if there's something wrong with networking. Maybe someone forgot a VLAN, or BGP is not peered on the other side, or things like that. And that's the nice thing about a true active. You can do that. You're not having to initiate a failover. That data store is globally available on all sites. The other thing also is this exception case where you have a site failure where the witness fails and then a site failures. We basically have the ability to go initiate that takeover. And it will run pre-checks. It will update the metadata and object hierarchy, and basically crowbar the quorum system to do that. That is a manual intervention, just because, again, we don't want a scenario where, because of perceived outages from network inconsistency, we don't want to challenge CAP theorem to a duel and end up with both sides active. But this is something that we support, and what customers have asked for this. Generally, this is a pretty extreme scenario. And this isn't something I normally see happen, but it's one of those tabletop exercises we want to make sure people feel covered in. VCF does have the ability now, also, as I said earlier, we have the ability now to support not only vSAN stretch clusters for storage clusters, but also be able to present those out. And so we can have these stretch clusters that are basically acting as a stretch storage platform that then can provide that to stretched compute clusters. And we will have full HA working and site aware, and we will optimally route that data so we don't end up doing a Lua pathing on the inter-site link between the sites. This is something that is always been a real benefit of vSAN, is stretch clustering and metro type capabilities has always been really complicated. And not to throw shade, it is complicated historically, but vSAN's made it really easy to configure. And it's just baked into the licensing. There's not additional licensing. You don't have to use things like FCIP gateways. You also get to, from a quorum device, you've just got a single witness VM that you can stand up that's really easy to deploy, and it scales down and up. You can build a 2-node stretch cluster. You can also build a giant stretch cluster. So it's a system that's really scalable, and it's interesting just how much adoption on stretch cluster we have. It's very broadly deployed, very cost effective, easy to do. And remember, you can do RAID, and by default, you'll do RAID within a site. So you can do that RAID 5, RAID 6 protection within a site, and then mirror between from a data protection standpoint. So I wanted to level set. So we've talked about the capabilities, but I also just want to talk a little bit about where we are at in the year 2025 on storage and the ecosystem and what vSAN looks like. So the drives that we're certifying today are TLC NVMe drives, and we do support the read-intensive drives. So these are drives with 1 drive write per day. The street price I'm seeing on these drives is about 18 cents. If you're buying from a server OEM who has some margin and markup, I'm generally seeing in the low 20s. And this is, again, before deduplication and compression and unmap and thin provisioning and things like that. So NVMe, I know some customers were kind of confused when we made vSAN ESA NVMe only. The drives actually don't really cost more than SAS drives. And when you remove the need for a RAID controller or an HBA, NVMe effectively is, the same price or cheaper in many cases at this point. From a density basis, I'd also encourage you to go look at some of these new hardware form factors. We're seeing 1U pizza boxes with 20 drives supported. There's even some out there now starting to come out with more drive slots. So if you start looking at 16 terabyte drives and you start putting 20 of these at a host, you're 256 terabytes raw before dedupe and compression. Stack 30 hosts in a cluster, at 7 point something petabytes raw before data reduction. The amount of scale that we can get into a host is incredible. And I'll remind everyone to go look at form factors. I know some people, they've been buying 2.5-inch drives for the past 10 years, and they want to keep buying those. We do have these new form factors that are fun, and they are supported. And this is how you get 20 of these drives in a 1U pizza box. And the density on these drives is pretty incredible in terms of capability. So, I've had customers say that HDI, well, it doesn't scale to my needs. If you can put, again, before data reduction over 7 petabytes in a rack, that's quite a lot of storage. In fact, some people are starting to become uncomfortable with just the density, from a blast zone of where all this does. But from a cost basis, if customer already has VCF and you view it as a sunk cost, your effective cost, you're getting, very, very low. This isn't something that I view as, a weak area or a concern in regards to that. I think we're going to be really, for existing VMware customers who invest in the ecosystem, we're going to be really one of the lowest cost storage options. And that's just with the drive choices today. So I just want to end on a note here of reminding everybody that vSAN is the built-in storage option that comes with VMware Cloud Foundation. And really, we're expecting to see a lot of adoption. We're excited about where this is going and encourage you to check out all the other videos as part of the VCF 9 series. Thank you.